So this is the power supply setup. Right here we have the AC to DC 12 volt converter, which powers the step down converter, which turns 12 DC to 5 volts DC. Also 12 volt DC, which powers the LT370 variable resistor, or the variable power supply, which we can control with the voltage and current knobs. These two power sources, one is varying, one is only set to 5, is sent to this relay, which we can decide what the output might be. This relay here, which I built, it controls the fan toggle, which can also be controlled over automatically when the temperature of the sensor increases up to 75 degrees Fahrenheit. Now, this here is the current sensor, which is sent SPI to the Arduino Uno. As you can see here, as of now, we're getting a 3 volt reading, and the outputs are connected to my multimeter here. And just to verify, now if I turn it to increase the voltage, you can see that it does have an accurate output. So does this meter here. This is used just for simplicity. It's not part of the project. Now, if I use the on-off switch, which is switch number 1, it turns it to the lowest possible output voltage, 0.8, which is not useful for most, and is verified there. Now we can turn it back on. Good, it goes back to the adequate voltage. Now, the second feature is the output swapping, which turns from the variable power supply to the designated 5 volt only. And it's shown here, and here, and here as well. Every time the button is pressed, it triggers one of the relay channels. Off, on. And when it's at 5 volts, when I change the value of the variable power supply, it does not affect the 5 volts. However, when I switch it back, everything's back to normal. Now another feature is the fan toggle, which is controlling this from the DC fan. When I turn it on, it turns off, or it turns on the fan, and I can toggle it manually. However, another additional feature is the temperature sensor, which controls the automatic sensing of the fan. As we increase the temperature, currently 69 degrees Fahrenheit, if we increase the temperature, the temperature shoots up past 75, fan is on. As it automatically decreases, pay attention to the value here. Good. It drops below 75 and the fan automatically stops. Now, everything can be logged onto this app, which is sent through Wi-Fi over this chip, the ESP8266 chip. As you can see, there's a temperature and the humidity, which is provided by this sensor. And we have data logging capabilities, which show us the trend of the temperature and humidity increase. This is a live view. You can have 6 hours. So the spike here is when I breathed into it, and it jumped up accordingly. Now, also down here, we have the voltage and current. The current usually stays at 0 because there's no load we're giving right now. But as you can see, the voltage on here is 7, and that shows a 7.9. This is because I cannot send float values, which is what this current is reading, over Wi-Fi. They only accept a byte size, which I can only do integer. So it takes the most significant number and excludes everything after. And let's see again. So pay attention to this indicator LED as we increase the temperature again. As you can see here, 75 and 75. And the fan is on. The cooling light is also on. As it drops below 75, it turns off, and the fan turns off accordingly.